Okay, so I'm going to be going over the first two problems in the introduction to microscopy flip it physics homework. I feel like these are just really good fundamental equations and concepts that we're using in class, so I thought I'd go over them. Well, anyways, our first one is an object is placed 12 centimeters from a lens with a focal point length of 10 centimeters. What is the linear magnification of the image? First thing that we need to do is take account of the core concepts or equations. The main concepts and equations we're going to be using here is the thin lens equation and the linear magnification. Thin lens equation is the 1 over distance of the object plus 1 over distance of the image equals 1 over the focal point, and the linear magnification equation is the magnification equals the height of the image over the height of the object, or it also equals the distance of the image over the distance object with the negative. How to solve this problem? First, we're going to take account of what we need to know, which we know the distance of the object and we know the focal point, so we need to find the distance of the image. To do this, you can use the thin lens equation and solve for di, which will give us the di of approximately 60. Once we have that, we can use this di plugged into the linear magnification and solve for our magnification. This problem plugs directly into the second problem, which is talking more specifically to conjugate planes. So again, this question asks, the object in the previous problem is now moved to the image conjugate plane. What is the linear magnification of the new image? So again, our core equations is going to be the linear magnification, but now we're going to be taking account for the concept of conjugate planes, which, as you can see here, which is a sketch from our manuscript, how the object and image in both these two conjugate images are pretty much just flipped. So moving into the problem, we can see that for DO, we're going to have 12 centimeters, and then DI, we're going to have our 60 centimeters, and our magnification, which we got in the first problem, really to get our conjugate plane, and you can kind of see how these numbers are flipped down here and would match up for this image. The distance to the object is now going to be 60, and then our distance to the image is going to be 12 in our next one, which gives us the linear magnification of negative 0.20067. Well, I hope these helped kind of explain the concept and